Alright, good morning Algebra 2 people, at least it's morning for me. Today we're going to be talking about lesson 1-4, which is graphing absolute value functions. Adjust the camera a little bit. Okay, so just a quick definition of absolute value. I usually like to, ask the class this at the time when we're face to face and say, hey, what's absolute value? And see what you guys say. Technically, absolute value is the distance a number is from 0 on a number line. Meaning, when I ask you the absolute value of something, you're always going to answer something positive because distance is positive. And think about that. If you say, hey, I'm driving over to the Lakes Mall, it's about 5 miles. You don't say, well, I'm going to go there, it's 5 miles, I'm going to come back here, it's -5 miles. You don't put mileage in terms of positive and negative, you don't put distance. So that's the same thing. Absolute value is the distance a number would be from 0 on a number line. So it doesn't matter if you're at the +5 on the number line, you're 5 from 0. If you're -5 or at -5 on the number line, you're still 5 spaces from 0. So when you hear, people associate, absolute value is always positive. That's because absolute value is a distance. We're going to talk about graphing absolute values and what those graphs look like and what their shapes are and how we draw them. We're going to start the discussion and the examples by making a chart, an old-fashioned XY chart, so we can do a number of things like, what's the shape look like? What should the shapes look like? And then start learning shortcuts. So ultimately, by the end of this lesson, we should not be making XY charts. We should be graphing them according to patterns we learned in the early stages of this video. These first 3 examples are going to answer a number of those questions to start. All right, so here we go. We are going to graph the basic, what we call parent function, y equals the absolute value of x. Yes, these 2 lines are the absolute value lines, and I have picked, I was going to say chosen, I have picked 0, 3 positive numbers, and 3 negative numbers. That's a good place to start with absolute value. We're going to make that chart, we're going to plot those points and make some observations about the graph as we draw it. In other words, plug these 7 numbers in, take the absolute value. In other words, ask, how far from 0 is it on the number line? So, guys, if I start with 0, the absolute value is 0 is 0. Meaning, if you're at 0, you're 0 spaces from 0. You're at it. +1, the absolute value of 1 is 1, 2 is 2, and 3 is 3. Meaning, 1, 2, and 3 are 1 space from 0, 2 spaces from 0, 3 spaces from 0 on a number line. It then so happens that the absolute value of -1, -2, -3 is also 1, 2, and 3. Because this is 1 space away, 2 spaces away, 3 spaces away from 0, just in the other direction. They're both the exact same distance from the 0, just in opposite directions, and therefore we answer the positive. Now, if we plot this graph, okay, so that's all I would need to draw this graph. 0, 0, 1, 1, 2, 2, 3, 3. So, if all you picked was those numbers and didn't get into the -1, -2, -3, you might be saying, hey, this is going to be a straight line. That's going to change because this is 1 left, 1 up, 2 left, 2 up, 3 left, 3 up. So 1 left, 1 up, 2 left, 2 up, 3 left, 3 up. And we see a V shape emerge. That is the shape of all absolute value graphs. So some things I want you to start noticing about this, because everything that we now do, we're going to compare to this original, because this is the original. Meaning the vertex, the point of the V is called the vertex. The vertex is normally at 0, 0. And this has sort of a rise over run slope feel of 1. Think of this from this origin. This is rise 1, run 1, rise 1, run 1, rise 1, run 1. But to get the other side of the V, it's rise 1, left 1, rise 1, left 1, rise 1, left 1. So you're going to hear me talk about that eventually, about this rise over run, but it's a little bit of it's different than just regular straight lines, because the only way to get a V is to rise 1, go right 1, and then rise 1 and go left 1, and make sure that you create that V. This graph, so let me elaborate. Absolute value graphs should have the shape of a V. And if they don't have a shape of a V, we need to alter the table at this point. Please note, by the end of this lesson, we're done making charts and tables. We're going to graph it by patterns. So if for this one, what if I did the exact same thing? Did 0, 1, 2, 3, negative 1, negative 2, negative 3, and try to make this chart. So understand there's like an order of operations to this one now, because I don't just plug a number in and take its absolute value. That's all I had to do here. I have a number inside here, so my order of business is as follows. Plug the number in, add 2, then take the absolute value, which means distance. So if I plug in the 0, 0 plus 2 is 2, absolute value is 2. Plug in the 1, 1 plus 2 is 3, absolute value is 3, meaning 2 is 2 away from 0, 3 is 3 away from 0. Please understand, I'm not saying, wait, 0 is 2 away. No, you're adding 2 to your number and then absolute value. Okay, 2 plus 2 is 4, absolute value is 4. 3 plus 2 is 5, the absolute value is 5. Keep going now. Negative 1 plus 2 is 1, absolute value 1. Negative 2 plus 2 is 0, absolute value 0. Negative 3 plus 2 is negative 1. The absolute value of negative 1 is 1. We are going to draw this graph, and we are going to notice the patterns. The x's need to go 1, 2, 3, negative 1, 2, 3, and it looks like the y's need to go all the way up to 5 this time. 1, 2, 3, 4, 5. So if I plot these points, 0, 2, right there, 1, 3, 2, 4, 3, 5. So far it looks like a straight line. Negative 1, 1. Okay, a little weird here. Still looks like a straight line. Negative 2, 0. Still looks like a straight line. Negative 3, 1. So you guys, we finally see where the V shape's gonna happen. Now a lot of times in class I'm like, hey, does that finally look like a V? And they're like, no, it looks like a check mark. You're right, it looks like a check mark. But understand, if I were to choose more numbers after this, like negative 4, negative 5, negative 6, this side of the V would form. You guys, a V shape technically only needs the vertex and 1 point on each side so I can draw the V. It just so happens that this side has 1, 2, 3, 4, 5, 6 points to draw that straight part, and this side only has 2. So yeah, it looks a little lopsided because of my board space. Still a V. Okay? Still going this way forever, still going this way forever. Now, please note something, because this is where you start noticing the shortcut. Like, what do numbers do that are inside the absolute value lines with a plus or a minus sign? Look at this. From where this opened at the origin, that's 2 to the left. You know, some people are like, wait a minute, that says plus 2. Should have gone this way. It does not go that way. See, to get this point, negative 2, 0, you needed the absolute value to be 0, and you needed a negative 2 to counteract the plus 2. That's why, so we say that this graph moved left 2 spaces of the origin to form the V. And it's still got what I call that rise 1, run 1 fact. It's rise 1, run 1, rise 1, run 1, rise 1, run 1. This side is more defined than that, but the left side's doing the same thing. It's rise 1, left 1, rise 1, left 1, rise 1, left 1. It's still there. Just don't have all the points there. Okay, next. We're going to use the same values again. 0, 1, 2, 3, negative 1, negative 2, negative 3. This time the plus 2, I used the same example, just put the 2 in different places. This time the plus 2 is on the outside. What does that affect? Okay? Now this time the order that I do the work in, like plug in, like here, I had to, in this very specific order, plug the number, plug the x value in, add 2 to that number, and then absolute value. This time, I plug the number in, absolute value now, add 2 after the fact. Watch the effect this has. So I'm literally going to be asking for the absolute value of these numbers, and then add 2 to them. So the absolute value of 0 is 0, add 2. Absolute value 1 is 1, add 2. Absolute value 2 is 2, add 2. Absolute value 3 is 3, add 2. The absolute value of negative 1, negative 2, and negative 3 are positive 1, positive 2, and positive 3. So understand that. So absolute value is 1, plus 2 is 3. Absolute value of negative 2 is 2, plus 2 is 4. Absolute value of negative 3 is 3, plus 2 is 5. There's my chart as I go to graph it. I will go 1, 2, 3 to the left, 1, 2, 3 to the, right, then left, and I do need to go 5 spaces up. So 1, 2, 3, 4, 5. As I plot this, you're going to notice there's more of a symmetry with this one. 0, 2 is right here. 1, 3. 2, 4. And then 3 right, 5 up, 3, 5. So there's those things. And then 1 left, 3 up. 2 left, 4 up. 3 left, 5 up. That V is back to symmetrical. You see it very clearly. So understand then what happens to numbers that are outside of the absolute value symbol back here with a plus or a minus sign. That graph is 2 higher than the origin. See, this is the original parent function right here. Instead of opening from the origin, this is up 2. So in other words, numbers that are plus or minus after the absolute value, move it in that direction. This was moved up 2. And currently it still has that feel of what we call a slope of 1, even though it shouldn't be called a slope, but it's got that slope feel. From the vertex, it's rise 1, run 1, rise 1, run 1, rise 1, run 1. That gets that side of the V. And then you run left to get the other side. Rise 1 left, rise 1 left, rise 1 left. You have that. So you guys are starting to get that feel now. So we're going to now start transitioning to making these graphs without the chart. I'm going to pause and get new examples. Okay, so you guys, the final 4 examples, we're going to use what we learned in the previous 3 examples, and these 4 examples we're going to learn from the previous 3 examples. And we're going to take those shortcuts. And you have to remember, if worse comes to worse, you got to go back and make a chart. Now, I would prefer you not have to, but that's where you got to like back up the video and look at those examples again and get this under control. So we now know, here's what you were supposed to figure out. if there is a number inside the absolute value plus or minus to the x. That's going to be your left or right moving number, and it moves the opposite of the sign. Okay, so pluses, x pluses go left, x minuses go right. Okay, like here, and here, and here. And I feel like I wrote that example wrong now that I'm looking at example 5. Yeah, there's supposed to be a -4 stuck in right here. We'll take care of that. Okay, so we've then also learned, so again, repeat. Inside the absolute value sign, x plus or minus, that moves the graph left or right. And it moves the opposite direction of the sign. Numbers that are after the absolute value sign, plus or minus, they move the graph up and down, and they are sign specific. Plus up, minus down. And then we're going to go back to that. Look at examples 6 and 7 have a number in front of the absolute value. Those numbers are going to be, for lack of a better name, called the slope numbers. Slope is straight up from the previous lesson, rise over run. That's for straight lines, but because of the V, we're just going to kind of adapt to it. Those numbers are going to be a rise, run both directions to make the V. So we're going to talk about that. So please understand the first 3 examples that were on the board, and then these next 2, there's not a number in front of the absolute value. That's where that rise 1, run 1 came from. If there's a different number, so this is going to be interpreted as a rise 2, run 1. And this, because it's negative, is going to be interpreted as a drop 3, run 5. We'll get there. So first of all, the direction interprets where your vertex is going to be. That's the point of the V. So, and I always write symbols up here so that I stay on it, because it's a little backwards this. So -3 does not move the graph to -3. It moves it right 3 spaces from the origin. That's where the vertex is going to be. There's not a number up here to move it up or down. 3 spaces to the right of the origin. Right here. At 3, 0. That's going to be the vertex. Because there is not a specific number out in front, we interpret it as a 1. This is a rise 1, run 1 scenario. So rise 1, run 1. And that's not it, because then that would be a straight line. You also have to start over and go rise 1, left 1. So your run always has to go left and right to form a V. That's why it's like not really a slope. It's just a helpful tool. So rise 1, left 1. You guys, technically, I only need 3 dots total, 3 points total to make a V. Provided the 1 is the vertex, 1 is the right direction, 1 is the left direction, and I got all I need. So there we go. And that might not be super duper accurate. I think technically it runs through this point right here. If I was to get all picky and such. If I really did the rise 1, left 1 thing, it crosses right there. So we'll be a little more accurate. But ultimately, there's the shape. I didn't have to make a chart. I could make a chart. I could make a chart and check all the values, and I'm going to get that same. In other words, you're going to find the vertex is at 3, 0. Think about it. If you put a 3 in there, 3 minus 3 is 0. The absolute value is 0, 0, 3, 0. There's your first point, and that works out. Okay, coming over here. The number inside the absolute value sign is your left and right number. It is reverse direction. So this is going to go left 5 spaces the origin. Folks, the number after the plus or minus number after is up and down. It is direction specific. So this is going to go down 4. So you guys, from the origin, you're going to go left 5 spaces, down 4 spaces, put a dot. 1, 2, 3, 4, 5, down 4, that's like right here. That is your vertex. We do not have a number in front. When we don't have a specific number in front, we call it a 1. That's a rise 1, run 1 situation. So rise 1, run 1. Rise 1, run 1. That's all I need to have the V. I can get more specific. I can certainly rise and run more if I want. Because sometimes some people like, no, where does it really cross the y-axis? I want it to kind of be in the right spot. So if I'm like right here, I could like rise 1, run 1. Okay, so I can see a few more dots. You know, and I get a little more specific because I can rise 1, go right 1 as many times as I want. And then this one, I don't need to be as specific. I'm going to stop short in my workspace. Not saying that it's a check mark. It's just I've drawn a more extended version of this side of the V than that. And this does keep going this way, just crosses into that workspace. Okay, so now we're going to start exploring with the fact that there's a number out front and there's a slope involved there. First things first, get your left-right business down, and then we'll go from there. Inside the absolute value, plus or minus, is the left and right, and it is reverse direction. So this is left 1, not to positive 1, but back 1. This is up 4. So from the origin, left 1, up 1, 2, 3, 4. Our vertex to our V shape is right there. Folks, this 2, I'm going to put it as 2 over 1. That is the number that we treat somewhat like a slope. Meaning it's rise over run, but it's also run left. It's rise, run right, rise, run left. We have to do both to get the V shape. So it's rise 2, run 1. So from here, rise 2, run 1, rise 2, left 1. In other words, it results in a steeper V, picture. And that should happen. If your rise is bigger than the run, you're rising farther, then the V is more steep and narrow. If the rise is smaller than the run, like the next one over there, it's a rise 3 situation, but a run 5, we're going to get a wider opening, flatter V. So there's that. Last but not least, people, for this particular video, just looking at the time here, making sure I'm staying under 30 minutes. So now you have the order of business. We look at the left-right, we look at the up-down, we put our vertex. And then lastly, which is so weird, the last thing we look at is the first number after the equal sign. So this gets dealt with last. Okay, so this is going to tell us right 4 spaces. Remember, the left right is reverse. Up 6 spaces. That's where the vertex of this V shape is. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Okay, so right there. Now, the negative means the top number, the 3, is a drop. In other words, this V is going to be upside down, kind of more looking like an A shape, but there's not the cross of the A. It's an upside down V. So you're going to drop 3, run 5. So you can see here, this particular graph, I need a little more space because I don't have enough room to run 5. So there's 1, 2, 3, 4. Let's get this little piece out of here. Right there. So from here, I got to kind of watch this. So we're going to drop 1, 2, 3, run 1, 2, 3, 4, 5. So we're like right here. 1, 2, 3. Yeah, right about there. And then we have to go left 5. So when after the drop, 1, 2, 3, we got to go 1, 2, 3, 4, 5 is right here. And there's that V. That's kind of going off your screen, but you get the point. That's an upside down V, and it's kind of spread out. Why? Because the drop is less than the run, so it causes it to be that way. So you guys, you have everything you need. You can rewatch parts of these videos, and please understand, you should understand how the table worked if I need the table, but you should be trying to transition towards not making the table, knowing the things that move it left and right, knowing the things that move it up and down, and knowing how to handle the rise-run situation. It's a rise, run one direction, run the other direction. It could be rise or fall and do that, okay? So you should understand that, and you have enough to see with those 7 examples, okay? That marks the end of lesson 1-4. Good luck, everyone.